Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 114, flatten binary tree to link the list. Given the root of a binary tree, flatten the tree into a linked list quotation mark. The linked list should use the same tree node class, where the right child pointer points to the next node in the list, and the left child pointer is always null. The linked list should be the same order as pre-order traversal of the binary tree. Example 1. So this binary tree is 1. So in this case, in this example 1, so given this binary tree, the output should be 1, and then 2, because 2 is 1's left child, and then 3, because 3 is 2's left child. And then for node 3, no more left child left, so we backtrack, and then node 4. And then from node 4, since this is left node, we backtrack, and then node 5, and then from node 5 does not have left child, so we check the right child. So node 5 goes to node 6, and then node 6 is left node, we backtrack. So in this case, the output should be 1, 2, 3, 4, 5, 6, in the same order as the pre-order traversal of the binary tree. For example 2, the input root is empty, so the output is empty list. And then if the input root is just itself, it just output itself. So how to solve that? So the first idea is to solve this one using a stack. Basically using a stack to keep track of the order of the traversal. So we want to make sure that this should be in the same order as the pre-order traversal. So the idea of using stack is to put the node onto the stack and then pop the node from the stack so that we can maintain the order. So for example, for this node, we want to make sure that we first visit all the left child before we backtrack. So in that case, when we encounter a node, we first put the right child onto the stack, and then we put the left child onto the stack. So that in that case, when we pop the node from the stack, we first pop the left child. So that's the key idea. We also want to use to keep track of the previous node and then the current node, so that we can also maintain the order and then let the previous node's right child pointer point to the current node. So that's kind of our idea. So let me write down the idea. So this is DFS using stack. So we have a stack. So for this stack, we first put right child onto the stack, then left child. So in that case, to make sure, we first pop or visit the left child. So this is follow the pre-order traversal. And then the second piece is we need to have a previous pointer. And then this one, the right equals the current node. And then previous dot left. So that's the main idea. We need to have a previous node to keep track of the previous node so that we can point previous node's right node to the current node. So in that case, let's try to code. So first we want to check the edge case, if not root. So in that case, we just directly return that. Else, let's construct an empty stack. We want to, so the first previous node is our root node. And then the stack, initially we should initialize the stack. If root dot right, so in that case, we first put that onto the stack. If root dot left child is not none, So in that case, we put the left child onto the stack. Okay, after the initialization, we have a stack. We also have a previous node. At the very beginning, the previous node is the root node. Since we already take care of the edge case, that is, we don't have the root node is empty node. In that case, we already directly returned, so we already handle the edge cases. So in that case, let's check the stack. So while stack is not empty, we just pop the node. So that's our current node. The current node equals stack.pop. So we pop the current node from the stack. And then for this current node, we check. So if current nodes are right, then we put the right child onto the stack. If current node left child is not empty, we put the left child onto stack. So after checking and determine, after completely visiting this current node, and then put the corresponding right child and left child onto the stack. If the right child or left child is not empty, after that we should update. Do the update. Let the previous node's right child pointer points to the current node. And let previous node's left child pointer set that to none. And then after that, we should update our previous pointer, update our previous node. So we have completely visited the previous node. So let's say in this example, at the very beginning, the previous node is set to the root. So, and then we first put the, in the initialization, we first put the node 5 onto the stack, and then we put node 2 onto the stack. And then in this while loop, we pop the node from the stack. We first pop the node 2, and then we check the node 2, the right node is not empty. We put that onto the stack. So the stack contains added step. So in our example, so the stack contains the 5 and then 5 and then node 4. And then if current node left child is not empty, we put that onto the stack. So in this given example, it's 5, 4, and then 3. And then after we complete visit this node 2, we need to update. So currently the previous node is our root node 1. So we set the root node 1's right child pointer points to the current node 2. So in that case, it's point node 2. And then we set the root node 1's left child pointer into the none. And then after that, we complete visit the current node. So we need to update the previous node. So in that case, the previous node equals the current node. So let's run our solution. Let's submit our solution. Okay, so the runtime beats about 80% and memory beats about 40%. So that's our solution using DFS. So the key idea is to use a stack and then to maintain our pre-order traversal. And then the second key idea is to have our previous node and then make sure that previous node's right child points to the current node. And then at the end of visiting each node, we just update our previous node. So that's our DFS solution.